Okay, so let's look at a harder MadAsMaths question in trig identities and equations. So it's actually a question in 3 parts, 3 completely independent parts, and you're simply being asked solve these equations. So what you're going to do in each instance is try and reduce the equation so that it's in terms of only one trig function, be that tan, cos or sine. So you don't want to have a mixture. You basically need to rearrange the equation. Use whatever trig identity you know. See if you can rearrange it into something simpler. Could still perhaps be a quadratic, and from there you can reduce it further. Okay, so start with rearranging each expression first and then go on to try and solve for the given range. I think confusingly they've used theta in the first 2 questions, x in the third question. It's completely irrelevant, so it doesn't particularly matter which variable you use. Obviously make sure you do state the final answer in terms of the correct variable. Okay, so give that one a go when you can. Pause the video now. Okay, so for this first one, let's look at how we'd rearrange this. We're going to get 4 tan squared cos theta. So let's think about what tan is. Tan is the same as sine over cos, right? So I'm going to rewrite tan squared as sine squared over cos squared. That's the same thing. Multiplied by cos theta, I get 15. Now, there's cos squared theta on the bottom and cos theta here. So one of those coses is going to cancel. So this implies, so this is the same thing as sine squared theta all over cos theta equals 15, because I've cancelled that cos with the fact that this is squared. Then let's multiply by cos theta on both sides. And let's replace sine squared with what we know it's the equivalent to 1 minus cos squared. And the reason I choose to do that is so that it's all in terms of coses instead of having a mixture of sine and cos. Multiply out. And rearrange just to make it look a bit neater in terms of having the leading coefficient be positive. So what's that going to give me? Plus 15 cos theta minus 4 equals 0. And then you can either do a substitution or you can just write it out. The point is you're going to factorize this as a quadratic. If we just do it directly, we should end up with the following. So this tells me either cos theta equals a quarter, or, well, both are meant to be simultaneously, but not simultaneously. Both equations I'm writing here will give me the full set of solutions when you take all solutions combined. So cos theta equals a quarter, solve that. Cos theta equals minus 4, solve that. Cos theta minus 4 equals minus 4, that has no solutions, because of course minus 4 is exceeds the bounds of being between minus 1 and 1. So really we're just solving cos theta equals a quarter. Okay. I won't go into the full detail of solving this one. I'll just give you the answers for now, but make sure you take a moment, if you haven't already. Can you find the full solutions of this within that range? You should be able to do that without without assistance effectively. Okay. If you have managed to try that, this is what the answer would be. 75.5 and 284.5. Okay, and that's your answer to the first one. Okay, so let's look at this one here. What are we going to do here? Okay, let's remove the fraction by multiplying both sides by cos theta minus 2. Because fractions are quite difficult to solve in terms of having equations which are in your fractions. Then we're going to get 3 cos squared theta on the right minus 6 cos theta. Then on the left hand side, so I'm doing 2 steps in one here, I'm going to replace sine squared theta with 1 minus cos squared theta. Okay. So effectively that 3 plus 1 becomes 4. Okay. I'm just being slightly lazy here and sort of combining steps. Ideally you shouldn't do this. I've done a bit too much in one go there, but for the sake of brevity, those are the 2 steps we can do. And then a final bit of rearranging. Collect all the similar powers together. So we've got 3 plus 1 cos squared theta minus 6 cos theta minus 4 equals 0. Okay, so this just turns out to be a quadratic in this instance. If I divide both sides by 2, actually it becomes a little bit simpler, which I can do because the right hand side is 0. 0 divided by 2 is just 0. Okay. As a quadratic then, we get this. And then let's see if we then express cos theta in terms of the values it could take. We'll have cos theta can be 2, or cos theta can be minus a half. Okay, so for this factor here, cos theta would have to be minus a half to make that 0, and this one, cos theta needs to be 2. Cos theta equals 2, there's no solutions. So effectively, we're just solving this one, cos theta equals minus a half. Again, try and do it yourself first, but the final answer in that case, you should be able to get 120, presumably from your calculator, and then also figure out that the second answer is 240. And those are your 2 solutions. Okay, so then our final one. This one's got an interesting little trick in it, actually, so we have to watch out. Even though it looks quite simple. So we've got 2 sine x equals tan x. We can immediately write that as sine x over cos. Okay. And then where do we go from here? So what you might think is the following. You might say, okay, I'm going to remove sine x from both sides, effectively. So we end up with this, 2 equals 1 over cos x. Now that is valid in most scenarios, except for one. So what you need to think is, how are you actually getting from here to here? Well, what we're doing is we're dividing both sides by sine x, right? So 2 sine x divided by sine x gives me 2. Sine x over cos x divided by sine x gives me 1 over cos x. There is one situation in which you're not permitted to divide by something, right? If that something is 0, you can't divide by 0. And because it's a function of a variable, an unknown variable, we don't know if that's 0 or not. So we have to put in a little caveat, a little condition. We have to say this is valid for when sine x is not equal to 0. Okay. So then let's continue on, and we'll end up with 2 cos x equals 1, and that gives us that cos x equals a half. Okay, so this equation will be equivalent to this as long as we don't consider the situation when sine x equals 0. So what about if sine x is 0? Could that solve the equation? Well, if you look at the original, if sine x was 0, the left hand side would be 0, and the right hand side would also be 0. So sine x equals 0 is actually a valid possibility. So we've kind of got two paths to go here. We've got, this path here, and we've got another path, another possibility, which is that sine x equals 0. Okay, and then let's bring those, all those possibilities, we bring them together, and we end up with the following pair. We have sine x equals 0 and cos x equals a half. These are our 2 possibilities. And then effectively what we have is that, this original expression is equivalent to saying sine x equals 0, cos x equals a half. Okay. In each instance then, you're going to want to find what the values of x and, what each of the values of x are. Sine x equals 0 is nice and easy. When does the sine graph cross the x-axis? It crosses at 0, it crosses at 180, it crosses at 360, and so on. However, we're not including 360 because it's strictly less than. So let's go back. We just have 0, 180. When is cos x equal to a half? Well, you'll have to use your calculator, or perhaps you remember, hopefully you remember, what angle gives me a half when I apply cos to it. So cos of what is a half? Hopefully you can remember, it's actually 60, and that's a good thing to remember. 60 degrees, and therefore if you can visualize the symmetry of the cos graph, or you use cast, or you use some other method, you can determine the final solution will be 120. Okay, because cos of 120 is also a half. So then our final set of solutions, our final answer is, let's do a numerical order, 0, 60, 120, and, oh no, sorry, go back. Made a mistake. This is not 120. I did 180 minus 60 foolishly. It's 360 minus 60. 300. Okay. In numerical order, these are the answers. Can I put 4 numbers in order? That's the question. There we go. 0, 60, 180, 300. Okay, so those should be the solutions of this. And remember, in all cases, use your calculator, plug the numbers in to the original and check it makes sense. Does the left-hand side truly equal to right-hand side? Okay, at least there you have a sanity check then, that what you found should be correct answers. Cool.